first normal form is a property of a relation in a relational database. A relation is in first normal form if the domain of each attribute contains only atomic values, and the value of each attribute contains only a single value from that domain. Edgar Codd, in a 1971 conference paper, defined a relation in first normal form to be one such that none of the domains of that relation should have elements which are themselves sets. First normal form is an essential property of a relation in a relational database. Database normalization is the process of representing a database in terms of relations in standard normal forms, where first normal is a minimal requirement. Examples: the following scenario illustrates how a database design might violate first normal form. Domains and values. Suppose a designer wishes to record the names and telephone numbers of customers. He defines a customer table which looks like this. The designer then becomes aware of a requirement to record multiple telephone numbers for some customers. He reasons that the simplest way of doing this is to allow the telephone number field in any given record to contain more than one value, assuming, however, that the telephone number column is defined on some telephone number-like domain, such as the domain of 12-character strings. The representation above is not in first normal form. A design that complies with 1 minafarad, in the first normal form, the previous table can be represented in the following way. However, this database design does not meet the more stringent requirements of second normal form. A design that also complies with higher normal forms. Another design for the same data makes use of two tables, a customer name table and a customer telephone number table. This design is in first normal form. Indeed, repeating groups of telephone numbers do not occur in this design. Instead, each customer-to-telephone number link appears on its own record. With customer ID as key, a one-to-many relationship exists between the two tables. A record in the parent table, customer name, can have many telephone number records in the child table, customer telephone number, but each telephone number belongs to one, and only one customer. It is worth noting that this design meets the additional requirements for second and third normal form. Atomicity. Edgar F. Codd's definition of 1 minafarad makes reference to the concept of atomicity. Codd states that the values in the domains on which each relation is defined are required to be atomic with respect to the DBMS. Codd defines an atomic value as one that cannot be decomposed into smaller pieces by the DBMS, meaning a field should not be divided into parts with more than one kind of data in it, such that what one part means to the DBMS depends on another part of the same field. Hugh Darwin and Chris Date have suggested that Codd's concept of an atomic value is ambiguous, and that this ambiguity has led to widespread confusion about how 1 minafarad should be understood. In particular, the notion of a value that cannot be decomposed is problematic, as it would seem to imply that few, if any, data types are atomic. A character string would seem not to be atomic, as the RDBMS typically provides operators to decompose it into substrings. A fixed point number would seem not to be atomic, as the RDBMS typically provides operators to decompose it into integer and fractional components. An ISBN would seem not to be atomic, as it includes language and publisher identifiers. Date suggests that the notion of atomicity has no absolute meaning. A value may be considered atomic for some purposes, but may be considered an assemblage of more basic elements for other purposes. If this position is accepted, 1 minafarad cannot be defined with reference to atomicity. Columns of any conceivable data type are then acceptable in a 1 minafarad table, although perhaps not always desirable. For example, it would be more desirable to separate a customer name field into two separate fields as first name, surname. First normal form, as defined by Chris Date, permits relation-valued attributes. Date argues that relation-valued attributes, by means of which a field within a table can contain a table, are useful in rare cases. 1 minafarad the tables as representations of relations. According to Date's definition, a table is in first normal form if and only if it is isomorphic to some relation, which means, specifically, that it satisfies the following 5 conditions. There's no top-to-bottom ordering to the rows. There's no left-to-right ordering to the columns. There are no duplicate rows. Every row and column intersection contains exactly one value from the applicable domain. All columns are regular, that is, rows have no hidden components such as row IDs, object IDs, or hidden timestamps. Violation of any of these conditions would mean that the table is not strictly relational, and therefore that it is not in first normal form. Examples of tables that would not meet this definition of first normal form are, a table that lacks a unique key. Such a table would be able to accommodate duplicate rows, in violation of condition 3. A view whose definition mandates that results be returned in a particular order, so that the row ordering is an intrinsic and meaningful aspect of the view. This violates condition 1. The tuples in true relations are not ordered with respect to each other. A table with at least one nullable attribute. A nullable attribute would be in violation of condition 4, which requires every field to contain exactly one value from its column's domain. It should be noted, however, that this aspect of condition 4 is controversial. It marks an important departure from Codd's later vision of the relational model, which made explicit provision for nulls. References. Further reading.